All right, we're going to talk about Poisson probability distribution. So a Poisson probability is a discrete probability distribution that applies to occurrences of some event over a specified interval. The random variable x is the number of occurrences of the event in an interval. The interval can be time, distance, area, volume, or some similar unit. The probability of the event occurring x times over an interval is given by this formula. So probability of x equals mu x, so the mean to the x power e to the negative mu over x factorial. E is approximately equal to 2.1828, so on and so forth. It's in your calculator, or just use the button in your calculator. Mu is the mean number of occurrences of the event in the intervals. Requirements for the Poisson probability distribution. 1. The random variable x is the number of occurrences of an event in some interval. 2. The occurrences must be random. 3. The occurrences must be independent of each other. 4. The occurrences must be uniformly distributed over the interval being used. Okay, so they have to have the same. So the parameters of Poisson distribution, the mean is mu, the standard deviation is the square root of mu. Okay, Atlantic hurricanes. For a 55-year period since 1960, there were 336 Atlantic hurricanes. Assume that the Poisson distribution is a suitable model. Find mu, okay, the mean number of hurricanes per year. Okay, so we want to find the mean. So what we're going to do is we're going to take our total here, total hurricanes divided by the number of years. So mu equals 336 divided by 55, or 6.1. So we expect 6.1 hurricanes per year. Find the probability that in a randomly selected year there are exactly 8 hurricanes. That is the probability of 8, where P of x is the probability of x Atlantic hurricanes in a year. So now the probability of 8. So now I'm going to use this Poisson item here. So I'm going to go mu, I already know it's 6.1, x is 8. So I'm going to go 6.1 to the 8th power times e to the negative 6.1 over 8 factorial, which is 0.107. So almost 11%. Okay? In this 55-year period, there were actually 5 years with 8 Atlantic hurricanes. How does this actual result compare to the probability found in part B? Does the Poisson distribution appear to be a good model in this case? Okay, so how many would we expect? So with the probability of 0.107 in 55 years, the expected number of years with 8 Atlantic hurricanes would be the product of this. 55 times 0.107, or 5.9, which is reasonably close to the 5 years that actually had 8 hurricanes, right? So 5, we expected 5.9, it was actually 5. So the Poisson model appears to work quite well, right? They're very, very close. Poisson distribution as approximation to binomial. Requirements for using Poisson as an approximation to binomial: n greater than or equal to 100, np is less than or equal to 10. So the formula for Poisson as an approximation to binomial is the mean equals NP. Okay? So main pick 4. So in the main pick 4 game, you pay 50 cents to select a sequence of 4 digits from 0 to 9. Okay? Such as 1, 3, 7, 7. So you can pick any 4-digit combination. If you play this game once every day, find the probability of winning at least once in a year. Okay, with 365 days. Okay, so the time interval is a day, and playing once per day results in n equals 365. Okay, so this is greater than. There are also one winning set of numbers among the 10,000, right? So the way we found 10,000 is there's 4 digits, 10 digits for each one. 10 to the 4th is 10,000 that are possible from 0 to 9999. The probability of winning is 1 in 10,000. With n equals 365 and the probability of 1 in 10,000 the condition of n is greater than 100 and NP is less than 10 are both satisfied, right? They're both satisfied, so we can use the Poisson distribution to approximate the binomial distribution. So I want the mu, we want the mean to be NP, so 365 times 1 over 10,000 is 0.0365, okay? So now, what's the probability of not getting a win, right? So we want the probability of not getting a win in 365 days, because then that gives me of at least once, right? I might win 2, 3, 4, 5, but if I don't win at all, I can subtract that from win. So I'm going to probability of 0. So my mean is 0.0365 to the 0 times e to the negative 0.0365, 0 factorial. Remember, 0 factorial is 1. So I have a 0.9642 probability that I will not win. So the probability of at least one win is 1 minus that, or 0.0358. Okay? And that's the Poisson distribution.